rule. Now let's study the chain rule. Now why is it called chain rule? And the other name of this chain rule is outside to inside rule. Now let's see why is it called like this. So let's assume the function is y is equal to f of gx. So this is my composite function, y is equal to f of gx. Now if you want to differentiate this function, this outside to inside rule says that first you differentiate the outside function, then you multiply it by the inside function's differentiation. So just see, mathematically we can write it as f dash of gx multiplied by g dash x. So this is the outside to inside rule. In words we can say that we differentiate, in words we differentiate the outside function, and multiply it with the differentiation of the inside function. Now guys, pay attention that when you are differentiating this outside function, you have to keep this inside function as constant. You have to differentiate with respect to this inside function. Right? Now this will be differentiation of f with respect to gx only. Okay, so pay attention about that. So let's do one more problem. Just note down this definition. This is very important for chain rule. So the next question is y is equal to tan of 5 minus sine 2x. Now guys, it's not necessary that it will be a composite function of only two functions. There can be a composite function, and inside that composite function we can have one more composite. Right? Here you can see that this is a tan function of 5 minus 2x, sine 2x. And this sine has another 2x in here. Right? So we'll deal with such kind of questions right now. So first of all what we'll do is y dash according to the outside to inside rule. What we'll do is we'll first differentiate tan x. So the differentiation of tan is sec square x. Right? So this can be written as sec square, and this inside will remain constant. So just pay attention, this inside will remain constant. This will be sine sec square 5 minus sine 2x. And then I multiply this result. Then I'll multiply with this result with the differentiation of this function 5 minus sine 2x. And the differentiation of 5 minus sine 2x is equal to, let's write it down first, d upon dx of 5 minus sine 2x. Okay. So now this function will stay as it is. This will be sec square 5 minus sine 2x. Now let's see the differentiation of 5 minus sine 2x. d by dx of 5 is 0 and d by dx of sine 2x. So this will be left with minus of d upon dx of sine of 2x. Now there are two ways of solving this differentiation of sine 2x. One of the ways is you write it as 2 sine x cos x. Right? Then you can apply the product rule. But the other way is you consider this as a composite function of two functions. The first one is sine u and the second is 2x. So when you are trying to differentiate this function, the differentiation will be the differentiation of sine u and then the differentiation of the inside function. Right? So this will be equal to sec square 5 minus sine 2x multiplied by, first I'll take this minus sign in the front, multiplied by cos 2x into the differentiation of 2x, and the differentiation of 2x will be 2. Now this is the constant multiple rule, that the constant comes out of the differentiation and we'll just have to differentiate x with respect to x, which is always 1. Right? So the final answer will be minus 2 cos 2x multiplied by sec square 5 minus sine 2x. So this is the final answer. Now let's see the chain rule for power functions. Now what will be the chain rule for power functions? We've already done one question on this one. Let's say now y is a function that is u to the power n, where u is some function in x. Okay. Now this u is some function in x, fx. So this can also be written as y is equal to fx to the power n. Now this can also be solved with the help of chain rule only. How? Because this can be considered as some function u, and then what we'll do is we'll first differentiate y with respect to u, and then we'll differentiate u with respect to x. So this value will be, now dy by du in this case will be equal to n u to the power n minus 1 multiplied by the differentiation of this function, which is equal to f dash x. So n u to the power n minus 1 multiplied by f dash x is the answer. Okay. So this is the chain rule for power functions. So let's see one question. Let's say we have a very complicated power. Y is equal to 5x cube plus 7 to the power 8. Let's say this is a given function. Now just try solving this problem with the help of chain rule only. What you have to do, the first step will be assume this function as u. Okay. So u is equal to 5x cube plus 7. So the y will become u to the power 8. Now try to solve this. Now the differentiation of y with respect to x can be written as dy upon du multiplied by du upon dx. Dy upon du will be equal to 8 u to the power 7 multiplied by du upon dx will be equal to 15 x square. Right? Now the differentiation of 5x cube plus 7. The differentiation of 5x cube is 5 times the differentiation of x cube. Now differentiation of x cube is 3x square, so this will be 15x square. Right? And the differentiation of 7, since it is a constant, that is equal to 0 always. So this will be 8 times u to the power 7 multiplied by 15x square. Now the value of u is 5x cube plus 7. So this is 8 times 5x cube plus 7 to the power 7 multiplied by 15x square. So this will be the final answer. So 120 times x square into 5x cube plus 7 to the power 7. So this will be the answer to this question. Now I'll give you some problems and try to solve these problems and match the answer after 5 to 10 minutes. Okay, by pausing the video. The first problem is, let's say we have 9 times tan of x by 3. So this is the first one. The second one is e to the power 4x square plus 3. And third one is fx is equal to sine of sine x. So just try these 3 problems. And once you solve these problems, you will have a nice understanding about derivative of a composite function. So now I'm going to solve the problem. The first one. Now in this case, y dash or f dash will be equal to, now this 9 will make no difference here. Okay. So first of all, I have to differentiate tan of function. So the differentiation of tan will be equal to sec square. So this will be equal to secant square x by 3 multiplied by the differentiation of x by 3. Now the differentiation of x by 3 can be written as 1 by 3 only. Since 1 by 3 is a constant, it will come out of the differentiation and we have to just differentiate x only. So the answer will be 3 times sec square x by 3. Right? Now see this case. This function is e to the power some function, let's say y. So first of all I have to differentiate e to the power y, and then I'll differentiate this function. So this is a composite function of two functions. The first one is e to the power y and the second one is 4x square plus 3. So the differentiation will be equal to y dash is equal to e to the power 4x square plus 3 multiplied by the differentiation of 4x square, which is equal to 8x. So now let's see the differentiation of sine x. So y dash will be equal to, first of all differentiate sine of u, right? Don't consider this function the inside function. First let's move on from the outside. So the differentiation of sine x, first step will be differentiated sine u, this will be cos of sine x, and then you will differentiate the inside function which is sine x. So the differentiation of sine x is equal to cos x. So this is the answer to the third one. So I hope now you're clear with how to